plus and we got minus here.
Yep.
And our body is a wire. So electricity go through us. I can show you. Have a look on the potato and also on the screen. Try to have both of them. So I have one here and one here. Have a look here. I tap here. So we got a dummy here. It goes. And when I push like this, it jumps and it jumps. So we close the circuit.
And
so we close the circuit.
Using this program, and
it goes like this. Wow. It's just a matter of electricity.
you can also have different.
Okay. How about that?
Yeah. So the kids they really like it. You know, kids can play video game at home. You know, you got a joystick you play. You know, but with this they really like it. Yeah,
okay.
They do. Yeah. All right. Well, this is just one of the things you can do with stand.
Okay.
Not too much, but we like it.
So tell me your name again. Michael.
Yeah.
And your organization is Make a Generation. All right, you're the founder and CEO.
Founder, CEO. I want here. There we go.
All right, thank you, Michael.
Good test. You know these things. It's really good. How about this one? Put your fingers in here, then put your fingers in your ears, and lean over so it doesn't touch you. Only you can hear this. You can't hear anything else.
I like the idea of like sitting on a beach for a day is like
it's exactly the same illusion. So which direction is the arrow pointing?
Both directions.
Yeah, and see when you look at it in the mirror, it's pointing the other way.
I know.
That's a cool illusion. Now what's this
What's the
for?
trick? Is that a reverse mirror or something? Or?
No, this has the exact same illusion. So what shape do you see?
What shape do I see?
Yeah.
Well, those look kind of like stars. Those look kind of like footballs.
Okay. Now what?
Oh wow! All diamonds.
Yeah.
Wow.
See, the key is the shape of the upper surface here. It's not flat. So it tricks our eyes into thinking we're seeing. I can see diamonds here. You're probably seeing the two circles, diamonds around them.
So is that the same thing happening with the mirror?
Yes. Yeah, exactly. Okay, which way is the arrow pointing?
That way.
now. Here's the one. Look at this one.
Oh wow.
It always appears to be pointing in the same direction. But if you look at it head on, like that, and you look closely, you can see how the top surface is shaped.
Okay. Very nice. Thank you, sir.
Sure, thank you. Did you see our ultrasonic levitator here?
What's this?
Well, it's called an ultrasonic levitator. Those little discs are speakers. They're mounted on a concave surface, which creates a sound field that is strong enough to hold the little pieces of paper there up there.
Which way is the arrow pointed?
And remember, sound is just a pressure wave.
So that's all sound.
Yes.
There's no breeze or no kind of.
Right.
Oh, how about that?
In fact, if we blow on it, we can just knock them all out of the device there.
And so there's sound coming from here and it's reflecting off? Or bouncing off?
No, it's not reflecting. There are speakers on both sides. They're all generating sound in phase. so that creates what's called a standing wave in the middle. And since they're curved, it constrains the piece of paper from falling out the sides. Of course, if we push on it, we can get
Because this is a steam engine, and we don't have any live steam here. So. Anyway, it's run by a Raspberry Pi.
So a steam engine, like on a locomotive?
Yes, very similar. This will run on steam. I just happen to be running it on forced air right now.
Okay.
Yeah, so
So if you let the air in, this will start moving?
yeah,
Wheel?
what the story is, this is a model of Pearl Street Station, New York, circa 1882. That's the first power station in the United States. So 400 lights were illuminated to 82 customers back in 1882, and this is a model of the technology used at that time. This is an Edison bipolar dynamo.
Okay. So is that the whole battle between Edison and Tesla, or
Yeah,
JP
Edison
Morgan?
lost, but he was first with power in the U.S. And my addition to this project is a Raspberry Pi running Python to control it.
The what?
It's a Raspberry Pi running Python that controls it. So this is a mix of modern technology with 1880s technology.
Okay.
So you can start seeing
So the robot solving the cube on its own? Wow.
Not doing anything. Yeah, it will scan. It scans all the colors and takes 2 seconds to calculate the steps, and then does the steps. But never when it's solving, it doesn't ever recalculate. It just keeps doing what it originally decided.
And the Mindstorm's doing everything, right?
What's the Mindstorm?
That's the
Like
program.
it's a Lego part you buy, and it's
And the
brain.
algorithm's downloaded.
So you build it on your computer and you upload it into the brain.
Just like on that magnet you made, so you gotta complete the circuit. You put a hand, you now put a hand in. What you can do, look.
It's pretty cool. It's upstairs.
That's awesome.
So is this like Lego stuff, or is this 3D printed? What is this?
This is a program that we have in Reston. It's part of Fairfax County Tech Program.
Yeah.
So what they do is we have a teen center, and within the teen center we have a tech program that is geared towards engineering and science.
Okay.
So what they do is the kids just play pretty much, but they build stuff like the helmet or like a robot, depending what their interest is. So it's based on a concept that was developed by MIT many years ago.
Yeah.
Which is like a media lab concept.
Yeah.
So the idea is kids come with different ideas, different concepts.
Yeah.
And we try to guide that and to do something productive with that.
Okay.
So it can be pretty much graphic design, whatever they have in mind.
Okay.
Yeah.
Thank you.
You're very welcome.
whole thing. And I saw your sign, and I'm kind of big on STEM outreach myself.
Oh, good.
Can you say a few words about the Children's Science Center and what it is, where it comes from? And
Yeah. So the Children's Science Center, right now, we have a location at Faire Mall. We have plans to build a larger facility out towards Ashburn. Some years down the line, we'll see when. But what it is it's a science center that kids can come and do some science. We've got a room that's all about engineering. It's called the Tinker Shop, and kids can build different things. We've got a sort of a chemistry, area. It's called the Experiment Bar. And so people will do, of course, you got to do slime. About 100 different varieties of slime. Or you can do other things. We've got, in the past, we've done things like DNA extraction or chromatography, different fun things like that. We've got camps.
Yep.
We've got, we go to schools. This is something that some junior hires built in the program. This back here was built by some junior hires. And this goes off to schools. So our school assembly program uses a lot of different components.
Okay.
And if we make giant smoke, just tons of fun. We do a lot of different.
Okay, thank you very much.
There you go.
So, sir, what's the exercise here? Are they just taking stuff apart, or?
So there's two reasons for this. One is to get people interested in like the mechanics of things and figuring out how things go together by taking them apart. And the other aspect is there's a recycling aspect here where the stuff like this gets donated, but it isn't eminently recyclable in this form. But the component parts are. So we take the plastic off, we take the metal out, we take the e-recycling bits like this out, and then it's far more recyclable.
Okay.
Mine's not in
That is stripped.
So hello and welcome back to Big Discussions. My name is Dr. Anwar Yusuf Dunbar. I am the owner and the creator of this channel and the founder of the Big Words blog site. All that information is on the banner for this channel. Today is June 2nd, and as you can see, once again, I have a guest.
Hello, hello.
My brother Amal is back.
Back in the building.
We are in Northern Virginia, in Fairfax, Virginia, at the Maker Faire, and we're at the Maker Faire at George Mason University. And I have to give my brother credit for me being here, because if not, I'd be at home in the air conditioning, just relaxing. So, why did you want to come to the Maker Faire? What made you decide to come?
I wanted to see. I wanted to reconfirm what I was feeling about STEM fairs of this nature. STEM being science, technology, engineering, and math. After having visited 3 STEM fairs, of this type, I was beginning to notice a bit of a pattern. There were vendors and makers who were commercial ready. They had commercial ready products. There were vendors and makers who were students and part of student groups. And there were vendors and makers who were about to graduate, but didn't really have any idea of how they could apply what they had learned in school, in high school, or in college to make money right now. I think that is one of the things that is missing in high school and in college, is that high school and college instructors and teachers and professors don't teach their students how to make money right now. So I wanted to visit another STEM fair to reconfirm my beliefs. My beliefs are confirmed. I actually spoke to a George Mason University group that builds dune buggies, and I asked one of the seniors at the table, how are you guys going to make money once you graduate? and she said there are several companies within this area that are looking to hire mechanical engineering students. But the answer that I was looking for was I was looking for more of an entrepreneurial take within her answer.
Okay, so that brings up a really good point, which I'm going to talk about in the future, which is that science, a lot of the luxuries and inventions that, and the technologies that we take for granted now were actually created by people who are not formally trained in a science. You know, they didn't go to college to get a bachelor's degree or a PhD or a master's. They were just people, thoughtful people, bright people who were able to assimilate information, look at things and wonder how they worked, and then they were able to solve problems by the inventions they created. Now, this week I want to start making a series of videos on some of the sciences I've been trained in, and I'm going to start with the basic sciences, and then I'm going to talk about what basic research is. So I thought that this would be the perfect intro to that. One thing I get asked quite a bit as a minority STEM professional from other minority parents, but I guess this is for all parents, is how do I get my children involved in science? And it just dawned on me when I was walking through the Maker Faire today, this is for children. And, well, it's in large part for children.
There are a lot of kids here.
There are a lot of kids here, and if you hear some noise in the background, there are people bringing out electronics and gadgets that kids were in there actually taking apart and hammering because they wanted to show those kids how some of these devices work, and they wanted to get them used to building and taking things apart and using their hands, and that's a huge part of science. Let's see, what else? So consider taking any young person in your circle to a Maker Faire that's in your area.
Absolutely.
At the beginning of this video, you just saw a montage of some of the things at the fair. There were some a lot of 3D printing. There were kids, as I just mentioned, there were kids breaking things up and putting them back together. There were robots figuring out Rubik's Cubes, and one table actually had some sound waves, and he was able to balance some little pieces of paper just from the sound waves. So there's really some very fascinating things at venues like this. And science is all about thinking, imagining, and then putting those ideas into motion somehow. Whether you get a degree or not, anyone can do science. And an example of this, and we're going to close this out pretty soon, is blockchain technology. There are a lot of individuals who are training in blockchain who are able to go out and get paid right away, and who are making large sums of money just by understanding how to write that code. And that kind of piggybacks off of what Amal said not long ago. So with that, do you have anything else? What do you say?
You know, don't be afraid to pursue your passions. Before I got to high school, I put away the part of me that enjoys tinkering. I put away that part of me that loved to take things apart and then put them back together. Or the part of me that loved to create items from scratch or from spare parts. I picked it up 4 years ago, but that's a part of me that was dormant for a long time. Primarily because I didn't think that part of me was valuable, but it is. If that part, if you have that creator or that maker inside of you, don't be afraid to tinker.
Okay. And piggybacking off of that, science is all about thinking and imagining and just coming up with ideas. That's a large part of it. I got a lot of compliments on my shirt today, which is the periodic table. There you go. So for any young person watching this, don't be afraid to show your love for science. And with that, I think we will conclude. Watch out for my next video on the basic science. And that we will see you next time. Bye-bye.
Peace.